Okay, Year 12, I'm going to go through some of the other questions from exercise 5.2. I'm going to very quickly do 19D and 19E. So 19D is pretty easy. So 19D, which is cos squared x minus sine x equals -1. So I could solve this, but I need to write cos squared x or sine squared x in the other trigonometric ratio. Luckily, you should remember that, and it's on your maths formula sheet. So the maths side, the trig identity of sine squared x plus cos squared x equals 1. I'm pretty sure it's there. I'm looking for trig. And factorisation, different trapezoidal logs. Should be under trig. There it is. It's under trigonometric ratios and identities. Sine squared theta plus cos squared theta equals 1. So you're able to use this. So sine squared x plus cos squared x equals 1. We've got the cos squared x, so I'm going to take that sine squared x over the other side. I'm going to get cos squared x equals 1 minus sine squared x. And that allows us to substitute 1 minus sine squared x into cos squared x. So I get 1 minus sine squared x minus sine x, and that equals -1. So I take everything over the other side, and that means I subtract that -1. So I get sine squared x plus sine x minus 2, because I minus that 1. Now this is an equation reducible to a quadratic. So what I'm going to do is I'm going to let u equal sine x. And I'm going to get 0 equals u squared plus u minus 2. Right, so now I need something that multiplies out to 2 and -1, or -2 and 1. So that's going to be u plus 2, u minus 1, which means u will equal -2, or u will equal 1. And that means sine x equals -2, or sine x equals 1. And we know from the sine curve that sine x can never equal -2 because it bounces between 1 and -1. So no solutions for that. And when sine x equals 1, well, that's pretty easy, because sine x equals 1, we can see from the curve, that's when x equals pi on 2, there, and minus 3 pi on 2. 3 pi on 2. I just checked 19C, D, pi on 2. Why hasn't she got 20D? Oh, yeah, that's silly, because that's -1. So it's only pi on 2. All right, let's do 19E. Now 19E is going to take a bit. Once we get the first bit out of the way, it's going to be hard. First of all, I'm going to do sine 3x. This takes a bit of work, and we've done it before. I think it's got sine 3x in it, doesn't it? Yes, it does. So sine 3x. So sine 3x is sine 2x plus x. And I use the sine rule, like a phi plus theta on the formula sheet, which tells me sine 2x cos x, and it's plus cos 2x sine x. All right, so I'm going to do sine x plus x and cos x. This is going to get really long. plus cos x plus x sine x. All right, so we've already done sine 2x, but here we go again. So it's sine x cos x plus cos x sine x. I'm going to put that all in brackets because that's the expansion of that. And I've got to have a cos x outside of it. Now, plus, now cos x is, and I'm going to put in brackets as well, cos x minus sine x sine x. And I'm going to have a sine x outside of that. So you can see it's pretty long. Now when I expand this, that's going to give me 2 sine x cos x. That's what's inside that parentheses. There's 2 of them. I'm going to go by cos x. So here I'm going to get cos squared x minus sine squared x. I'm going to sine x there. So here I'm going to get 2 sine x cos squared x plus, now when I expand these brackets, I'm going to get a sine x cos squared x. And here I'm going to get a sine cubed x. Well, that and that are like terms, so I'm going to get 2 plus 1, so I'm going to get 3. Oops, let's go back here. Sine x cos squared x minus sine cubed x. Now that's a lot of work, and they're not going to ask you that. But now, when I have to solve this equation, which is sine 3x plus sine x. So, sine 3x plus sine x. And what does it equal? 0. Well, I'm going to substitute this in here. So that gives me 3 sine x cos squared x minus sine cubed x plus sine x equals 0. Now I'm almost there, but the problem is I've still got that cos squared x. But remember over here, cos squared x what cos squared x? I'm going to substitute this in here. So I'm going to get 3 sine x by 1 minus sine squared x minus sine cubed x plus sine x. And all that equals 0. That'll give me 3 sine x minus 3 sine squared x minus sine cubed x plus sine x equals 0. And I'm a bit worried because I think I got a different answer to this before. I think I might have missed a negative there, so I'm just looking at my work from before today because I did this one. Anyway, I'll carry on. So that'll give me 3 sine x plus sine x is 4 sine x minus, and that's a cubed, 4 sine cubed x equals 0. Now let's take 4 sine x out. 4 sine x out, and I get 1 minus sine squared x equals 0. Well, that means either sine x equals 0 or 1 minus sine squared x equals 0, which means, well, sine x equals 0. What does that look like? Between 0 and 2 pi, well, that means x equals 0 or 2 pi. 2 pi there. Or sine squared x equals 1, which means sine x equals plus or minus 1. Therefore, x equals the inverse sine of plus or minus 1, which we know is going to be pi here, this point, which is pi on 2, or 3 pi on 2. So I'm going to get pi on 2 or 3 pi on 2. So x can equal 0, pi on 2, 3 pi on 2, or 2 pi. And if I check my answers for not there, there we are. Oh, I missed one. Pi. Oh, of course, I missed pi in here. That was a bit of a mess up, so I can have pi as well. All right, hopefully that helps you with question 19.